Dear students, in exercise 12.3 of quadrilaterals, we are having question number 6 first. In a rectangle PQRS, O is the midpoint of PQ. Show that triangle POS is congruent to triangles QOR. As you can see that this is a rectangle, so angle P will be 90 degrees and angle Q will also be 90 degrees. Also PS will be equal to angle QR because in rectangle opposite sides are equal and all the angles are of 90 degrees. So one thing more is that when O is the midpoint of PQ, so PO will be equal to OQ. So these three things will help us to prove that triangle POS is congruent to triangles QOR. So according to this, we will start writing here. First thing, in triangle SOP and triangle ROQ. PO equals to OQ. PO equals to OQ. We will write the reason here. O is midpoint of PQ. Second thing, angle OPS. Angle OPS equals to angle RQO or OQR. OQR. We will write the reason here. Both 90 degrees. Third thing, PS equal to QR. PS equals to QR. Give reason. Opposite sides of a rectangle are equal. So these three things will help us. So this is the side, this is the angle, and this is the side. So by SAS congruence criterion, triangle POS is congruent to triangle QOR. Hence proved. Next is question number 7. In a rhombus QRST, diagonals QS and RT intersect at O and angle QRO equals to 65 degrees. Find the angles of the rhombus. So we can see that QRST is a rhombus. So rhombus has opposite angles equal. Its all sides are also equal. So we know that the diagonals of a rhombus bisect each other at 90 degrees. So point of intersection, that is O, will be a 90 degree angle. So let us write here. In right angled triangle ROQ, angle ORQ plus ROQ plus angle RQO will be equals to 180 degrees, because the angle sum of the of a triangle is 180 degrees. Now ORQ is already given to us 65 degrees, ROQ is 90 degrees, and we can easily find now RQO. Adding these two, we get 155. Angle RQO equals to 180 and angle RQO equals to 180 minus 155. Angle RQO equals to 7 minus 5 is 2, 25 degrees. As we have got that RQO, that is this angle is 25 degrees. Also we know that QR is equal to RS. So these two sides are equal. So this creates an isosceles triangle. In an isosceles triangle, the base angles are equal. So angle RSQ will also be 25 degrees. Next, we know that alternate angles TSQR. So this angle will be copied here using alternate angles. Okay, and using alternate angles, this 65 degrees will be copied here, because this makes a Z shape here. Whenever there is a Z shape, the alternate angles are made. Now again, QR is equal to QT. So QR and QT are two equal sides. So this also makes an isosceles triangle. So in isosceles triangles, where two sides are equal, the base angles must be equal. So this 65 will be copied here, 65 degrees. Now this 25 degrees will be copied here using alternate angles like this. Okay, TQSR, also making the alternate angles. Similarly, this is the alternate angle of this 65 degrees, QTRS. So this is also making a Z shape. So this 65 will be copied here. Now just we have to conclude that QRS is the sum of 65 and 65, and the opposite is QTS. So let us write it. Angle QRS equals to 65 degrees plus 65 degrees equals to 130 degree, and its opposite angle QTRS will also be equal to 130 degree. Opposite angles of rhombus are equal. Next, angle TQT QR equals to 25 degrees plus 25 degrees, that is 50 degrees. So angle TSR will also be 50 degrees. Right here, opposite angles of rhombus are equal. This is question number 7. Next is question number 8. One of the diagonals of a rhombus is equal to the side of the rhombus. Find the angles of rhombus. So here we can see that it is given in the question that diagonals of a rhombus is equal to the side of the rhombus. This is the diagonal. Suppose this is A, B, C, D. So AC diagonal is equal to one of the side. So let us take this one side. When it is given that DC is equal to this, and we know that in a rhombus all the sides must be equal. So when DC is equal to this, then it is equal to this, because in the rhombus all the sides are equal. So DC is equal to DA, and AB and BC, all the sides of this rhombus are now equal. Now you know that when three sides of a triangle are equal, they make an equilateral triangle. An equilateral triangle has all the angles 60 degrees. So this is 60 degrees, 60 degrees, 60 degrees, and this 60 is copied here because opposite angles of a rhombus are equal. So using the interior alternate angles rule, we can say that this 60 degree will be copied here, because we can see that there is a Z shape, D, A, C, B. So this 60 will be here. Similarly, for this, the Z shape that is made is D, C, A, B. So this 60 will be copied here. Now we can say that angle ADC equals to angle ABC equals to 60 degrees. DCB equals to 60 degrees plus 60 degrees, that is 120 degree, and this will be as here, angle DAB equals to 120 degrees. This is the solution. Next is question number 9. In a rectangle ABCD, BP and DQ are perpendicular to the diagonal AC. Is BP equal to DQ? Justify. We have to justify. So let us first make the rectangle ABCD. Now BP and DQ are perpendicular on the diagonal AC. A, B, C, D. So AC is the diagonal, and BP is the perpendicular. Perpendicular means right angles. right angle, this, and DQ. So to prove that, to check that BP is equal to DQ, BP is equal to DQ, first we have to prove that these two triangles are congruent. To prove these two triangles congruent, we must have three things: equal. Okay, so first we'll write here in triangle DQA and triangle BPC, three things that we have to prove. First is AD is equal to BC. Okay, AD is equal to BC. What will be the reason? The reason will be that opposite sides of a rectangle are equal. Opposite sides of a rectangle are equal. Second thing is that angle DQA equals to angle BPC. They are perpendicular. Perpendicular means both 90 degrees. Third thing, we can say alternate is DAC, DACB. So angle DAC will be equal to angle ACB, or we can say that these two angles according to these small triangles, angle DAQ equals to angle BCP, saying that alternate angles. Are equal. So here we have side angle, or we can say angle side, because side angle does not exist, but angle side exists. Angle side. Congruence rule, triangle DQA is congruent to triangle BPC. So when the two triangles are congruent, we can say that BP is equal to DQ, because these two sides are the part of these two triangles. BP is equal to QD. QD, yes. BP is equal to DQ. By CPCT rule. The full form of CPCT is corresponding parts of congruent triangles.